All right, so here is where we are at. We are trying to find extrema, either relative or absolute. The first step, any sort of extrema question that you're given, is that you must find the critical numbers. To find the critical numbers, technically you look at f prime is equal to 0 or does not exist, and they need to be interior to the domain. So you have to think about what is the domain of the function. Now, that is true for any of these questions. You need to find the critical numbers. Now, there are two scenarios that can happen. If it is a closed interval, that is going to be a square bracket A to B. That is going to have a different process than when there is no interval given, or you can really just think about it as it's not a closed interval. All right, so if it's not a closed interval, it's going to be a different process. Now, when it is not closed, you have two options once you have those critical numbers. The first option is that you can use the first derivative test. And the first derivative test, again, is that number line where you plug in to the first derivative and you figure out if you have a positive or a negative, increase, decrease, there's my relative maximum. The other option, so again, I can use the first derivative test, that's one option, or I can use the second derivative test. And with the second derivative test, we take those critical numbers that we found and we plug them into the second derivative. So we plug the critical numbers into the second derivative. And if the second derivative is positive, then we have a concave up function. And if we have a concave up function, a U-shaped graph, then we have a relative minimum at that critical number. Meanwhile, if the second derivative is negative, then we have a concave down function. And if we have a concave down function, then we have a relative max at that critical number. So when you're looking at something that is not a closed interval, you can use either of these methods. You can use the first derivative test or the second derivative test. The one exception is that if the second derivative gives you 0, then you have to default back to the first derivative test. So this first derivative test always works. Meanwhile, the second derivative test sometimes works / usually works. All right. Now, what we're doing in this section is we are thinking about a completely different scenario. We are now thinking about it when it is a closed interval A to B. And when you have a closed interval, you're not going to have a first derivative or a second derivative step. What you're going to do when it's a closed interval is you are going to simply compare the y values. And you are going to compare those y values at the critical numbers and at the ends of the graph, the endpoint that you have. So here when I'm looking at AB would be those endpoints. Now, it's really important when you're looking at comparing y values that you are plugging into the original function. So we're going to use what is the highest value, what is the lowest value of that original function. So this is our overall process for finding extrema. Again, the very first step is critical numbers. Every single time, if they say find the extrema, you must find the critical numbers. Then if it's not closed, you have options. You have the first derivative test or the second derivative test. Meanwhile, if it is a closed interval, then you are going to compare y values. And this closed interval process is our new process in this next section.